Okay, on to question 5. So we've got a question on radioactive isotopes, and we can see we're given the atomic number, or the, oh my god, my handwriting's terrible. That's the worst I've done. That's the atomic number or the proton number, and this is the mass number. So we know that's the number of protons, also the number of electrons, and we know that the mass number is the protons plus the neutrons. So for me to work out the neutrons, I just take away those two numbers, or I subtract those two numbers. So how many protons are in the nucleus? Easy. The smaller number of the two. Remember, it's not a bottom. It's not a bottom top thing. Sometimes they'll flip those two numbers over. So just forget it's the smaller number of the two. How many neutrons are there? Well, 90 take away 38 equals 52. B. The half-life of strontium-90 is 29 years. The table gives the changes to mass. Complete the table. So I've taught you the following. If I take the activity at the start and I write st for start, all I have to do then is half it for each half-life. And we can see, okay, well, the missing value is over 2 half-lives. So after 1 half-life, this will go to 800. This one, if it's halved again, it must have taken another set of 29 years, and that's it. So your values to go in that table there are, well, half 1,600, done. And the next time is, if it's fallen by half again, it's another set of the half-life, so it's another 29 years added on, and that's 58. Teacher sets up an experiment, so hopefully you remember this and me demonstrating the sources. State the scientific name for the radioactivity detector. So its posh name is a Geiger-Muller tube. You'd be absolutely fine with a Geiger counter. So that is a Geiger counter. If you want to show off, call it a Geiger-Muller tube. On to the next one. Teacher has a radioactive source that only emits beta. And I've got a meter ruler. State 2 precautions the teacher must take to protect herself from the effects of radioactivity. Any of these. Always make sure you point the source away from people. You'll notice I did that. I even checked there was no one on the playground and things like that, so I don't zap anybody. Handle the source with forceps and tongs. You'll remember that I picked it up with the metal device and had gloves on. So that's on to the next one. Use gloves, wear a mask. And then the other one we could add in there is limit the exposure time. So if you were to use particularly hazardous sources that schools are not allowed to have anyway, then you could wear a badge monitor. So it literally tells you your dose at the end. Next question. Describe how the teacher could show how far beta particles travel. Now, what loads of students did is they started talking about putting metal in front of it. That doesn't tell you how far. So the basic idea for this is get a Geiger counter, put the beta source, I'll put a B, right next to it, all right, and move it away. But clearly, before I do that, I need to know when to stop, and we know that we've got background radiation. So before we do anything with radioactivity in a Geiger counter, we leave it for a minute to just measure the background radiation. So job number 1, find the background radiation. Next one, put the beta source, so I'll have that as my beta source, right next to it. Measure the counts every minute as I gradually move it over there. When this gets to the point that it matches background, then I know that this is how far they can go. This distance here. Woohoo! So now let's turn that into full sentences. That's the basics. Always, always, always with radioactivity, just make sure you mention about getting background radiation first, so I've got a comparison, because the environment around us is radioactive. So first, measure background radiation. 1 easy mark. Next one, place the beta source right next to the Geiger counter. Next one, gradually move the source away, and we're just going to count the counts every minute. Stop when the reading is the same as background radiation. Clearly, there is no more beta now, it's just the radiation in the air. Put the source away and then measure that distance using a ruler. Oh, I've missed that out. So sorry, guys. I'm going to using the ruler. Ruler. That looks like Ruka. From wherever the source was. And I've tried to put a little safety thing in there. Is don't go measuring it with the source in your hand. That would be rather stupid. And that's that question done.